Hello YouTube. This is a tutorial on programming in Visual Basic. I am using Visual Studio 2017 Community Edition. You can acquire this edition of Visual Studio for free. However, you will need to create an account if you do not already have a Microsoft account. I have already created the project and solution. To do what I have done, you can press File, New, Project, and I selected Console Application under the Visual Basic tab. Under the Visual Basic tab, you'll see Windows Desktop, and then you select Console App. I'm going to press Cancel. This is the Solution Explorer, which shows your file structure within your solution and projects. Note that you will not see this Lamo project. Can have projects of different types in the same solution. Anyhow, we've created here a console application in Visual Basic, and you've got two levels of hierarchy already. You have the module. It is called, in this case, Module 1. Within the module, there is a sub-procedure called main. You can have many subs or sub-procedures within a module. We will learn about what these terms are in the future. Let us begin with our main. In other programming languages, if you are familiar with other programming languages, you will know that the program begins with main, especially within console applications. This is the entry point of our program in this case. Anything that happens in this program must first start here. So what we can do to begin is we can do a simple write line statement. So we would write console.write line. Now, as you see, it's going to fill it in. We could press enter and it'll fill it in. Or alternatively, we could hold down shift and then the left parenthesis, and it'll write it out and put our insertion point within the parentheses. This is very helpful. We can put within it quotation marks. So we hold down shift and press the quotation mark key, and we get a pair of quotation marks, and our insertion point, as you can see, is placed between them. So we can write hello world. That's a great way to test our application. You can press start or F5 to run the application. Now, it doesn't look like much happened, but a lot of things actually happened. For one, it saved our changes, it compiled our application, and then it ran it. Of course, the program didn't stay open, and I'll show you now how to fix that to keep it open. So you can put your insertion point right here, press enter a few times, and then you can type console.readKey. You can press enter, and then you can press F5 or start to run the application. And as you can see, it says hello world. So you have done two things by now. You have figured out how to get the program to say hello world in a terminal-like format, and then how to keep the program open. In Visual Basic, you can omit the parentheses of a method. This write line is a method. Read key is a method, otherwise known as a subprocedure. Main is a method or subprocedure. I should note my project settings right now. So if I go to my project and I go to compile, right now I've got option strict turned off. We should turn it on. It'll make us better programmers, and ultimately it's better that way anyway. So we've figured out how to write methods or subprocedures, rather to call them. You can also put the word call before a subprocedure call, and it does the same thing. You don't need to put call it's a feature that exists within the language, but it's unnecessary. So you can remove that. Run. As you can see, it still says this stuff. Okay, well, can I put anything within these parentheses? Let's find out. Yeah, it looks like it. If we make this long enough, we'll see that it line wraps onto the other line. What if, for example, we wanted to put a return character? What if we wanted to make it go to the next line? Well, if I do this, it won't exactly do that for us. See? What happens if I put this here then? Visual Basic will actually do it, surprisingly. Now what if I have two separate quotations? So as you can see, I have this quotation. I can add other information to this quotation, or append, if you will, using an ampersand. That is Shift and then the 7 key. I can do this, and I can add what is known as a integer literal. I can run, and as you can see, it appends an integer literal to the end. Now you might be wondering, well, couldn't I have just put the integer literal within these quotations? And you'd be correct. You could do that, and this might have foreshadowed that, as you can see. What if I don't want to specify things within quotations? What if there's a way I can just write it once in one place and then reuse that value or reuse that information in other places? Well, then you'd need to do variables, make variables. So put your insertion point right here, press enter a few times, and we're going to figure out how to make variables. So the way you do that is you define in memory. Use a keyword called dim. That means define in memory. Then you give your variable a name. It cannot have spaces in the name. It has to have no spaces. So no spaces. As you can see, I capitalized the first letter of the second word within this no space thing. And that is so it's easier to read. If I put a lowercase s, it's harder to read. So uppercase S. Now if you want to specify a variable in Visual Basic, you also have to specify the type it has. The way you do that is you write as, and then you choose your type. So if we want to do a integer literal, which is just a number, a whole number, then you type integer. Okay. Now what if we want to put in text? Could we use an integer? The answer is no. So you would go, for example, my name as string. Alright, well, we've defined variables, but we have not given them values yet. How do we do that? Well, afterwards says as and then the name of the type, you put an equals sign. This is an assignment operator, and you can put, in the case of as integer, an integer. In the case of the string, you can put equals and then quotations like we did before with the writeLine method or subprocedure. So within these quotations, we can write Jake or something. I don't know what your name is. This is not my name, but I thought of a name and I put it in there. So as you can see, we have a variable called my name, which has the value of Jake, which is a string value, and we have a variable called no spaces that's of type integer that is equal to 6,753. So we can take these variables and we can have the writeLine statement output them. So my name, and we can make another one, console.writeLine, no spaces. Notice that my insertion point did not go underneath the method when I wrote that, but you saw that I wrote it quickly. So you can do no, and then as you see it's right in this list here, you can press tab and it will finish writing it for you without putting the insertion point on the next line. What do I mean? Like, no, I could press enter, but as you see it puts me on the next line, which is not exactly convenient. So let's do no spaces and then hit tab, or no and then hit tab, and it'll write no spaces. So if we run the program by pressing F5, it outputs the value of these two variables. So the first one, it outputs as my name. And the second one, which is outputted, is the number. It can go even further than this. We could write no spaces plus 67, as you can see here. Now, what might the output be? So this was an addition operator. This is the addition operator. It added the value of no spaces to 67 and outputted it. What happens if we were to put the ampersand? As you can see, it does not add the number, but rather treats it like it's a string and strings it together, strings the values together. Not as math, but as strings. If we wanted to divide, we use this symbol. Run. And that's the division output. If we want to multiply, we don't use X like you think you would. That wouldn't work. You press the asterisk. Now, there is another operation you might not be familiar with. It is called modulus, and it gives you the remainder of two values. You'll understand the importance of modulus in future episodes, if I make a video on it, of course. Now, as I kept alluding to with the use of the ampersand, we can do some pretty interesting stuff. We can use an ampersand here after my name, and then we can have some quotation marks. In between the quotation marks we have one space. Then we can have after that perhaps no spaces. Whoops, I press enter. Now do not worry. I'm holding down Control and Shift, and then I'm pressing the left arrow key, and then I press the right arrow key so as not to consume no spaces. So that was, let me do it again, no spaces. I pressed enter mistakenly. It brought me down to this line, and it's quite a mess. I could just fix it with the mouse, or alternatively, I can hold down Control and Shift and then press the left arrow key once, twice, and then press the right arrow key once, and then I can press either delete or backspace, and that fixes it. Start, and as you can see, it wrote the name Jake, put a space, and then put a number. We can go further. We can write so this will read the names, possessive, age is, and then it'll have a space, and if we run, it'll say Jake's age is 6,753, which is hard to believe, but Jake is an old dude, apparently. So we have thus far figured out how to write our own variables, how to output them with right line statements, and we will figure out a bit more. What if we want to let's create another variable called my number, and we'll say it's as integer, and we will make it equal to 6.7. As you can see, we get a red underline, as if we had misspelled it. Rather, we didn't misspell it, but option strict points out that we cannot do implicit conversions from double to integer. What this means is that integers are whole values. This is a whole value. This is not. This is a fractional or decimal value. If we want to do decimal values, what we would do instead is to write either double or decimal. Let's go with decimal, as decimal is more accurate. If we are going to use decimal, however, we have to put a D after it to specify we're using decimal and not double. Why not use double? Whoops. Double my number 2. As you can see, you can't reuse the same variable name for a different variable. So dim my number 2 is going to be equal to 6.7. Whoops, do not, okay, 6.7. Actually, let's make these equal the result of a math problem. So no spaces divided by 67. No spaces divided by 67. Now let's put a D after this. There we go. As you can see, because it's decimal, we have to specify D after it so as it doesn't complain. Now let's press enter, or excuse me, F5. Oh, we did not output it, as you can see. Even though we did the mathematical operations, we did not output them. So down here we can write, whoops. So I wrote 2 right line statements. And we can write my number and then my number 2. And for fun, we can put some text before it that says value of my number. Value of my number 2. Now if we press F5, we can see the difference in the amount of decimal places it will go out to. See, my number 2 is of type double, whereas decimal is my number. So as you can see, it says the value is 100.791044777611940298507462687. I didn't want to bother reading it as like a... Anyway. Value of my number 2, which is of type double, it'll simply be 100.79 10 44 77 61 19. As you can see, it's missing a lot of decimal values, and you might be wondering why that is. It's because double uses less memory. That's the simple answer. Now you might be wondering, well, gee, wouldn't I be concerned with accuracy? Wouldn't I want things to be more accurate? And there is a point to that. So the trade-off you have is the decision whether or not you want to have more memory consumption but more accurate values, or whether you want to save memory and you don't care too much about the accuracy of decimal numbers. It depends on the usage case. If you're working with, for example, currency, you want to be as accurate as possible, so you'd want to use decimal. If you just want to do something really basic, double might be better for you. But just remember that to distinguish between a decimal literal and a double literal, you have to distinguish between a double and a decimal, you have to specify with the decimal that it has you give it a letter D, and it will be much more clear to the program. So thus far we have learned how to make variables. We have learned how to do math right here. If I wanted, I could have written math is not dependent off of variables. We've learned how to output statements, output variables, output strings. We have learned a little bit about modulus. We haven't gone too much further, but we've learned a little bit about modulus. And the one thing we have yet to learn, and this is for next episode, is about arrays. That is something you can think of as a list of things, a list of like-minded things. That's how you can think of arrays as. That's not exactly what an array is, but it's a pretty good working definition. One last thing before I end this video, as I've noticed that it's gone on for quite a while, is that